If you are good at solving equations, then you'll be good at solving inequalities also. The key thing to watch out for, as we have in the sentence here, is to be careful to change the direction of the inequality whenever you multiply or divide each side of an inequality by a negative number. Adding and subtracting a negative do not make a difference. It's just multiplying and dividing by a negative number, because the rules for multiplying and dividing negatives mean that you change the sign. I'll not go into an explanation here. So let's actually go through and solve a couple problems. So let's go through and solve a couple of problems. For each of the following, we want to solve and then put our solution set in interval notation. We will begin here by adding 6 to each side. Notice that addition doesn't change anything as far as the direction of the inequality. We're going to have negative 3w is greater than 15, and then divide each side by negative 3 to isolate that w. Now, whenever we divide by a negative, we change the direction of the inequality. So this is going to switch into a less than sign. We're going to have w is less than negative 5, and that is our solution written as an inequality. If we were to graph this on a number line, it would be an open circle at negative 5 with all values smaller than it shaded in. And in interval notation, we will have the set from negative infinity up to negative 5, not including the negative 5, meaning we use parentheses. Had we included the negative 5, we'd be using a bracket. Basically, this means all values smaller than negative 5, when substituted in, will make a true statement with that inequality. This next problem is a compound inequality, and this time our goal is to get the variable k by itself in the center. So we will add 7 to the middle, the left, and the right of this compound inequality, which will give us negative 1 is less than 4k is less than 18. And then we will divide all three parts by 4. Notice we are dividing by a positive 4, so the inequalities will stay as a less than symbol. So negative 1/4 is less than k is less than 9/2 after I reduce that fraction. If I were to graph this on a number line, we would have an open circle at those two values with the shading between the two numbers. And in interval notation, this will be the set of numbers from negative 1/4 to 9/2, not including either of those endpoints, as we denote by using the parentheses instead of the brackets. When we look at some word problems for inequalities, it's important that we have some notation down. This is sort of a code list to use. More than is usually a greater than symbol. Less than is a less than symbol. No trouble there. At least, however, is a greater than or equal to symbol. Most times we get a mistake there. If we need to spend at least so much money to guarantee our budget for next year, we have to spend more than or equal to that. At most turns out to be less than or equal to. You have a cap or a limit. If you can spend at most so much money on clothing in a particular month, that means you have a budget cap, and you can usually need to spend less than that. No more than means you want to be under or equal to, so that is a less than or equal to. And no less than means don't go under, you can equal or be greater than, so greater than or equal to. So these last 4 are ones that you want to pay attention to and really reason out and make sure you understand why these inequalities go with those phrases. Okay, this looks a little bit scary because it's a long paragraph, but most of it's just directions. Kira pays a monthly fee of $20, then she pays an additional 4 cents per minute for this phone service. Now let's think about that. That's going to be $20 plus 4 cents per minute. If she uses her phone for 1 minute, that's just 4 cents. 2 minutes, 2 times the 4 cents makes 8 cents added onto her monthly charge. So that's a standard pattern we use. The least she's been charged in a month is $64.76. I'll put 64.76 on the right, and we'll figure out the inequality in a little bit. What are the possible number of minutes she has used in a month? Okay, that means this is the smallest. She always has more than or equal to that amount, so that will be the inequality we use for this situation. Now let's subtract 20 on each side. We will have 0.04m greater than or equal to 44.76. Personally, at this point, I'm going to choose to multiply through by 100 to move the decimal to the right 2 places. Because I'm multiplying by a positive 100, the inequality stays a greater than or equal to symbol. And then dividing each side by m, I now have m is greater than or equal to 1,119. She can use 1,119 minutes per month to be at that monthly bill or above.